Hi, hello, my dear students. Very good evening to all of you. So, warm welcome to Master School Foundation program. So, by observing the yesterday class, so some students joined and so put their comments in live chat. So, I was very happy. So, actually, so by observing the last 1 week classes or 2 weeks classes, so most of the students were not there in the class. So that's why yesterday I requested them. So most of the students joined the class and followed the class. So I'm requesting you all the remaining students also. So please follow the classes regularly. So because now we are discussing the chapter functions. So it is the most important chapter with respect to IIT JEE examination. So 1 or 2 questions will come from this chapter in both mains and advanced examination. So that's why it is most important chapter. You may not have this chapter in your board syllabus, but this chapter is most important with respect to the IIT JEE mains and advanced examination. Here our aim is to get the best rank in IIT JEE examination. So that's why we are discussing the topics in the class which are the most important with respect to the IIT JEE examination. So that's why, my dear students, I am requesting you all. So please follow the classes. So without skipping. So please follow the classes every day and do the assignment problems which we are keeping in Master app. And alternate Saturdays we have the weekend examination. So please write the exam also. Then you can know the caliber of you with respect to the subject. Okay, now let us start the class today. Now in functions, in last class means yesterday, we discussed the domain rules, finding the rules of domain. When a function is in the form of 1 by f of x or 1 by root f of x or root f of x or log f of x, 1 by log f of x. When the given function is of any one of those 5 forms, then how can we find the domain? So for suppose that if we have the function of the form 1 by f of x or g of x by f of x, to find the domain of that function, we have to take the denominator as not equal to 0. If you have the function root f of x, if we have the function f of x under square root, then we can take f of x is greater than or equal to 0. So any value under square root is always equal to 0 or greater than 0. The value under square root cannot be negative. Okay. So today let us discuss the when 2 functions are there or 3 functions are there. So yesterday we discussed the rules for finding the domain for single functions. If we suppose that 2 functions are there, if only one function is there, then we can take that as f of x. If 2 functions are there, then let us take them as f1 of x and f2 of x. Okay. So if we suppose the 2 functions f1 of x and f2 of x are there, so we can find the domain of those functions. We can find the domain of those functions. Here, if we suppose that d1 and d2 are the domains of 2 functions y equal to f of x and y equal to g of x, 2 functions are there. So if there is only one function, then we can take that is y equal to f of x. But here we have 2 functions. If you suppose that the first function is y equal to f of x and here also y equal to g of x. If we suppose that the first function is y equal to f of x and the second function is y equal to g of x. For the function y equal to f of x, let us suppose that d1 is the domain. For the function y equal to g of x, let us suppose that d2 is the domain. If we suppose the 2 functions y equal to f of x and y equal to g of x are there, and let us take d1 is the domain of the first function and d2 is the domain of the second function, then to find the domain of the function, you may take f of x plus gx, g of x, or f of x minus g of x, or f of x into g of x is d1 intersection d2. We know intersection means we have to write the common elements of the given 2 sets. If A and B are given sets, to write the intersection of those two sets, we have to write the common elements of both A and B. So, if you suppose that A equal to 1, 2, 3, 4, and if you suppose that B equal to 3, 4, 5, 6. Now, to find the intersection of these two sets, intersection is nothing but A intersection B. Intersection is nothing but we have to write the common elements of the given two sets. Here the given two sets are A and B, where the set A contains the elements 1, 2, 3, 4 and the set B contains the elements 3, 4, 5, 6. By observing the elements of the sets A and B, clearly here 3 and 4 are the common elements. So, that is why we can write the intersection of A and B. We can write the intersection of A and B as 3, 4. So, A intersection B equal to 3, 4. Here also, if we suppose the two functions are there, let us take the first function as y equal to f of x and let us take the second function as y equal to g of x, and if we suppose that d1 and d2 are the domains of those two functions, then the domain of f of x plus g of x or f of x minus g of x or f of x into g of x as d1 intersection d2. We have to take the common domain of f of x and g of x. We have to take the common domain of f of x and g of x. So, that is why we may have f of x plus g of x, or we may have f of x minus g of x, or we may have f of x into g of x. If we have the two functions, any one of these three forms, first form is f of x plus g of x, find the domain of f of x plus g of x, find the domain of f of x minus g of x, find the domain of f of x into g of x, f of x plus g of x, sum of two functions, f of x minus g of x, difference of two functions, f of x into g of x. So, product of two functions. If we have the two functions any one of this form, we can take the domain as d1 intersection d2. We can take the domain as d1 intersection d2. d1 intersection d2 is nothing but we have to write the common elements of both d1 and d2. d1 set may have some elements, d2 set may have some elements. By observing the elements of both d1 and d2, we have to write the common elements only that represent the common domain, that represent the domain of f of x plus g of x or f of x minus g of x or f of x into g of x. If we have the function like this, f of x by g of x, f of x by g of x. So, in this case we can take the domain as d1 intersection d2 minus g of x not equal to 0. Here we are taking d1 intersection d2, but if we have the function like this f of x by g of x, to find the domain of this function f of x by g of x, we can take d1 intersection d2 minus g of x equal to 0. Here we are subtracting the denominator from d1 intersection d2, because here g of x lies in the denominator, g of x lies in the denominator, the denominator cannot be 0. The denominator cannot be 0. In numerator we may have any value except 0. In numerator we may have any value except 0. So, in the denominator if we have 0, then that is not defined. So, that is why here we can subtract g of x equal to 0. So, find the domain of f of x and g of x. Take d1 is the domain of f of x and d2 is the domain of g of x. So, find the common domain of those two functions by taking d1 intersection d2. From d1 intersection d2 subtract g of x equal to 0. Subtract g of x equal to 0. Then finally, you will get the domain of the function f of x by g of x. Finally, you will get the domain of the function f of x by g of x. So, here it can be useful when two functions are given in the given problem. So, find the domain of the function x square plus 1 by 3x. X square is one function, 1 by 3x is another function. So, here we have to find the domain of those two functions separately, and we have to take the common domain by taking the real number line. Next, so these are the most useful formulae while finding the domains of the given functions. Here, if alpha comma beta belongs to R, means real numbers, and alpha less than beta, Here alpha and beta are real numbers. You may take 2 comma 3 or 0 comma 5, 1 comma 8, minus 1 comma 2, root 2 comma root 3. You may take any two real numbers as alpha and beta, but here the condition is alpha less than beta. Alpha less than beta. If you suppose that beta equal to 3, in place of alpha you must take the value less than 3. Less than 3 means you may take 2.9, 2.8, 2, minus 1, minus 2, minus 10, like that. You may take any value in place of alpha that is less than 3 if you take beta equal to 3. So, if alpha beta belongs to R and alpha less than beta, then the first case is if x minus alpha and x minus beta less than 0, then we can take the domain as x belongs to alpha comma beta. If x minus alpha and x minus beta less than 0 means negative. So, by finding the product of x minus alpha and x minus beta, if we get a negative value means less than 0, minus 0.5, minus 1, minus 2, minus 10, like that, then the domain can be taken as open bracket alpha beta. Here the bracket is most important. Here x minus alpha and x minus beta less than 0. From this we can write x belongs to open interval alpha beta. X minus alpha and x minus beta less than or equal to 0. Here we have to take the bracket like this, not open bracket. So, in first case we have x belongs to alpha comma beta open bracket. In second case x minus alpha and x minus beta less than or equal to 0. In this case we can take x belongs to closed interval alpha beta. Here we can take the bracket like this. We can take the bracket like this. The difference between this bracket and this bracket is the difference between, so this is called the open bracket or curved bracket. This is called the closed bracket or square bracket. What is the difference between the curved bracket and square bracket? If you suppose that alpha equal to 2 and beta equal to some 5. If you suppose that alpha equal to 2 and beta equal to 5. The meaning of open bracket 2 comma 5 is we have to consider the values between 2 comma 5 only. Between 2 comma 5 means you may take 2.01, 2.02, 2.3, so 4.999, but don't take exactly 2 comma 5. But don't take exactly 2 comma 5. The meaning of this closed bracket 2 comma 5. In this case we can take both 2 and 5 also. Here we are not considering 2 comma 5. Here we are taking the values between 2 comma 5 only. So, if you take the bracket like this, here we are considering the values of x between 2 comma 5 only. Between 2 comma 5 means 2 point something to 4 point something. Don't consider exactly 2 or 5 in place of x. If we have the bracket like this 2 comma 5, the meaning of this bracket is you can consider 2 comma 5 also. You can consider 2 comma 5 also. So, the meaning of this bracket is you can take any value between 2 comma 5 including 2 and 5. But if you take the bracket like this, we can consider the values between 2 comma 5 only. So, already we discussed about those brackets in sets. So, open bracket 2 comma 5 means we have to consider the values between 2 comma 5 only. Don't consider x equal to 2 or x equal to 5. If you take the bracket like this, square bracket or closure bracket, in this case we can take all the values between 2 comma 5 and we can consider also the values 2 and 5. In place of x we can take either 2 or 5, but here in place of x don't take either 2 or 5. Don't take either 2 or 5, just we have to consider the values between 2 comma 5 only. But here we can take all values between 2 comma 5, we can consider also x equal to 2 and x equal to 5. So, if we suppose that alpha and beta are two real numbers such that alpha less than beta, then if x minus alpha and x minus beta less than 0 means that is clearly negative. X minus alpha and x minus beta less than 0 means that is clearly negative. In this case we can take the values of x between alpha comma beta only. Don't consider alpha and beta. Here we are taking the bracket like this. If x minus alpha and x minus beta less than or equal to 0, then we can take the values between alpha comma beta, and we can consider the values alpha and beta also with respect to the problem. While doing the problem, we may have less than 0 or less than or equal to 0 or greater than 0 or greater than or equal to 0. So, if we have x minus alpha and x minus beta greater than 0, if we have x minus alpha and x minus beta greater than 0, in this case here we have strictly greater than 0, here we have strictly less than 0. In this case we can take the values of x between minus infinity comma alpha or beta comma infinity. We can take the values between minus infinity comma alpha or beta comma infinity. So, for example, if we have x minus 2 into x minus 5 greater than 0. So, this is true only when the values of x lie between minus infinity comma alpha or beta comma infinity. So, if we compare this with this, in place of alpha we have 2, in place of beta and we have 5, x minus alpha and x minus beta, alpha equal to 2 and beta equal to 5. According to this formula, x belongs to minus infinity. X belongs to minus infinity comma alpha. Alpha means 2 union beta means 5 comma infinity. Minus infinity comma 2 union 5 comma infinity. So, you must take the values between minus infinity comma 2 or 5 comma infinity. For example, between minus infinity comma 2, if you take 0, 0 minus 2 into 0 minus 5. For example, if you suppose that x equal to 0, in place of x by writing 0, this will be 0 minus 2 minus 2, 0 minus 5 minus 5, minus 2 into minus 5 plus 10, clearly that should be greater than 0. Or we may take any value between 5 comma infinity. Between 5 comma infinity means if we suppose that 6 is there. So, 6 minus 2 into 6 minus 5. 6 minus 2 is 4, 6 minus 5 is 1, 4 into 1 is 4, clearly that is positive. If you take the values between 2 comma 5, for example, between 2 comma 5, let us consider 3. In place of x, if you take 3, we can write 3 minus 2 into 3 minus 5. 3 minus 2 is 1, 3 minus 5 is minus 2, this is minus 2, but this is less than 0. Minus 2 means that is negative. Negative is nothing but less than 0. So, that is why this is false. So, that is why x minus alpha and x minus beta greater than 0 means we have to take the values of x between minus infinity comma alpha or beta comma infinity. We can take the values of x between minus infinity comma alpha or beta comma infinity. Next, fourth case, if x minus alpha and x minus beta are greater than or equal to 0, here we have the bracket like this. If x minus alpha and x minus beta greater than or equal to 0, then we can take the values of x like this, between minus infinity comma alpha union beta comma infinity. Here the difference between this and this, here we have minus infinity comma alpha union beta comma infinity. Here also we have minus infinity comma alpha union beta comma infinity, but there is a difference in the brackets. Here we have taken the brackets like this, curve bracket. Here we have taken the brackets like this, square bracket. The difference between the curve bracket and square bracket is, if you take the bracket like this, don't consider alpha and beta, consider the values between minus infinity comma alpha or between beta comma infinity only. If you take the bracket like this, in this case you can consider the values between minus infinity comma alpha or beta comma infinity, including alpha and beta. In this case, we can consider the values alpha and beta. So, here while finding the domains of the given function, so brackets are most important. So, if we may have one option like this, 2 comma 5, and option B is given as 2 comma 5, and option C is given as 2 comma 5, and option D is given as 2 comma 5. For a particular problem, let us suppose that the 4 options are given like this. By observing all options, every option contains 2 comma 5 only, but there is a difference in the brackets. So, the difference between the open bracket and closed bracket is, if we take the bracket like this, we can consider the values between the least value and greatest value. If we take the bracket like this, we can consider all values between the least value and the greatest value, including the given values. If we take 2 comma 5 open bracket, so take the values between 2 comma 5 only. In this case, x lies between 2 and 5. In this case, x lies between 2 and 5. If you take the bracket like this, 2 comma 5, in this case we can take 2 less than or equal to x less than or equal to 5. 2 less than or equal to x less than or equal to 5. 2 less than or equal to x less than or equal to 5 means we can consider x equal to 2 or 5 or any value between 2 comma 5. If you take like this, 2 less than x less than 5, in this case we can consider the value of x between 2 comma 5 only. Don't consider 2 or 5. So these 4 points are most important. So let us recap them. Here, if you suppose that alpha, beta are real numbers and alpha less than beta. If x minus alpha into x minus beta less than 0, then we can write the domain as x belongs to open interval alpha beta, open bracket. This is also called the interval. X belongs to open interval alpha beta. If we have x minus alpha into x minus beta less than or equal to 0, in this case the domain of function can be taken as x belongs to closure interval alpha comma beta. X belongs to closure interval alpha comma beta. Closure interval is nothing but square bracket. Closure interval is nothing but square bracket. So x minus alpha and x minus beta greater than 0. The domain of the function can be taken as x belongs to minus infinity comma alpha union beta comma infinity. If we have x minus alpha into x minus beta greater than or equal to 0, in this case we can take the domain of the function as x belongs to minus infinity comma alpha union beta comma infinity. Minus infinity comma alpha union beta comma infinity. So how can we remember to which bracket is taken while doing the problem? So simple. If we have strictly less than 0 or greater than 0. So if we have the sign like this, so this is called strictly less than and this is called strictly greater than. If we have the signs like this, we must take the open bracket. So this is a open bracket and this is also a open bracket. If we have the signs like this, less than or equal to 0 or greater than or equal to 0, in this case we can take square bracket. But remember, for minus infinity and plus infinity always take open bracket only, because minus infinity and plus infinity are undefined values. Minus infinity and plus infinity are undefined values. So for alpha and beta only take the square bracket like this. If we have strictly less than 0 or strictly greater than 0 like this, then we can take open bracket for alpha and beta only. If we have less than or equal to 0 or greater than or equal to 0, if we have the symbol like this, less than or equal to 0 or greater than or equal to 0, in this case for alpha comma beta take square bracket. For minus infinity and plus infinity take always open bracket only, because minus infinity and plus infinity are undefined values. Now let us do some mains model problems related to the domain of a function. The problem is given as the domain of the function 1 by 2x minus 1. Here let us recap the rules of finding the domain. Rules of finding the domain. Here by observing the first rule, here if the given function is of the form 1 by f of x or g of x by f of x, in numerator you may have any value except 0. In numerator, when a fraction is given, in numerator you may have any value except 0. So but denominator cannot be 0. If the denominator is 0, then we know something by 0 is infinity. Something by 0 is infinity, that is nothing but not defined. Something by 0 is nothing but not defined. So that's why the denominator cannot be 0. The denominator cannot be 0. So by observing the given function, we have 1 by 2x minus 1. We have 1 by 2x minus 1, where the denominator is 2x minus 1. So this function is defined only when 2x minus 1 is not equal to 0. where the function 1 by 2x minus 1 is defined only when 2x minus 1, that is nothing but the denominator. So, when 2x minus 1 is not equal to 0, then this function will be defined. So, 2x minus 1 not equal to 0, here find the domain of the given function is nothing but finding the values of x only. Finding the values of x only, remember that. Find the domain of the function means we have to find the values of x which satisfy the given function. So, here also for this function 1 by 2x minus 1, find the domain is nothing but find the values of x. Here by taking minus 1 to that side, we can write 2x not equal to 1. If you take minus 1 to that side, we can write 2x not equal to 1, but here we have to find the values of x. So, that is why let us divide this expression on both sides by 2, you will get x not equal to 1 by 2, x not equal to 1 by 2. So, this function is defined, this function means 1 by 2x minus 1. The function 1 by 2x minus 1 is defined when x not equal to 1 by 2, when x not equal to 1 by 2. In place of x, if we take 1 by 2, we can write 1 by 2 into, here I am taking x not equal to 1 by 2. In place of x, if we consider 1 by 2, 1 by 2 into 1 by 2 minus 1, where 2 get cancelled, 1 by 1 minus 1, that is 1 by 0. So, this is infinity, means not defined. Something by 0 is not defined. In numerator, we may have any value except 0. If the denominator is 0, then we can write that is infinity. Okay, 0 by 0 is not defined. So, that is why in place of x, do not write 1 by 2. In place of x, do not write 1 by 2. So, in place of x except 1 by 2, you may take any value. For example, if you take x equal to 0, 1 by 2 into 0, 0, minus 1, 1 by minus 1 is minus 1, that is defined. So, for the element 0, we can say the image is minus 1. In place of x, if we take 1, 1 by 2 into 1, 2, minus 1, 1 by 1, so that is 1 only. So, the image of element 1 is 1 only. In place of x, if we take 10, 1 by 2 into 10, 20, minus 1, that is 1 by 19. The image of 10 is 19. So, by taking any value in place of x except 1 by 2, we are getting the known values. We are getting the known values. Known values means 1, 2, 1 by 2, root 3, root 5, minus 1, 0, 8, like that. So, this is unknown value. The 1 by 0 means in place of x, by taking 1 by 2, we are getting infinity. So, this is unknown value. Find the domain means we must get the known values of x. We must get the known values of x. So, that is why in place of x, do not write 1 by 2. In place of x, do not write 1 by 2. So, means on the real number lines we know, so 0 is the neutral number, all the numbers right side of 0 are positive real numbers and all the numbers left side of 0 are negative real numbers. So, here do not consider 1 by 2, 1 by 2 is nothing but 0.5. So, do not consider this. Except 1 by 2, you may take any value less than 1 by 2 or greater than 1 by 2. In place of x, do not consider 1 by 2. On the real number line, at x equal to 1 by 2, except 1 by 2, you may take any value. Except 1 by 2 means you may take any value between minus infinity comma 1 by 2, or you may take any value from 1 by 2 comma infinity. So, from the real numbers here, minus infinity comma infinity means that is the set of real numbers. Minus infinity comma infinity means that is the set of real numbers. So, from all these real numbers, you may consider any value in place of x except 1 by 2. So, that is why we can write domain of the given function is r minus of 1 by 2. You may take any real number other than 1 by 2. You may take any real number other than 1 by 2. So, that is why we can take option D is the correct option. We can take option D is the correct option for the given problem. So, first option is only 1 by 2. The meaning of this is in place of x we have to write 1 by 2. Here second option is 0 comma 1. Third option is r. R means any real number. Capital R means any real number. But out of all real numbers, here by taking x equal to 1 by 2, the function is not defined. So that's why we can eliminate option C. Here we have only one option, that is D. Here we have r minus of 1 by 2. R minus of 1 by 2. So the domain of the function 1 by 2x minus 1 is any real number other than 1 by 2. Any real number other than 1 by 2. That is r minus of 1 by 2. R minus of 1 by 2. So this is defined when the values of x are less than 1 by 2 or greater than 1 by 2. You may take any value between minus infinity comma 1 by 2. You must get the known value. Or you may take any value between 1 by 2 comma infinity. You must get the known value. So that's why we can take the domain of 1 by 2x minus 1 as r minus of 1 by 2. R minus of 1 by 2. R is nothing but minus infinity comma infinity. Minus infinity comma infinity. So except 1 by 2 you may take any real number. So this is also written as minus infinity comma 1 by 2 union 1 by 2 comma infinity. We are taking the values between minus infinity comma 1 by 2 and between 1 by 2 comma infinity. So you can express r minus of 1 by 2 like this also. Minus infinity comma 1 by 2 union 1 by 2 comma infinity. Here we are not considering 1 by 2. We are not considering 1 by 2. So that's why take open bracket. So not considering means we are not taking those values. So that's why take open bracket. So minus infinity comma 1 by 2 union 1 by 2 comma infinity, that is also represented as r minus of 1 by 2. R minus of 1 by 2. So we can write like this. So r minus a. A is some real number. We can write this as minus infinity comma a union a comma plus infinity. Here in place of a we have 1 by 2. So that's why we can express like this also. If we have the option like this, then we can take that is the correct option. So here we have used the first rule, 1 by 2x minus 1 is there. So take denominator as not equal to 0. So 2x minus 1 not equal to 0. Next here we have the domain of 1 by x square minus 1 into x plus 3 is. The domain of 1 by x square minus 1 into x plus 3 is. Here we have the options are 1 comma 3, r minus of plus or minus 1 comma 3, option C r minus of plus or minus 1 comma minus 3, and capital T is given as capital R. Here by observing the given problem, 1 by x square minus 1 into x plus 3, 1 by x square minus 1 into x plus 3 with respect to the first rule. Here the given function is of the form 1 by f of x. Here the function is in the form of 1 by f of x. Here we have x square minus 1 into x plus 3. Here we have the denominator is x square minus 1 into x plus 3. This function is defined only when the denominator is not equal to 0. This function is defined only when the denominator is not equal to 0. So that's why we can write here x square minus 1 into x plus 3 not equal to 0. X square minus 1 into x plus 3 not equal to 0. So from this we can write x square minus 1 not equal to 0 or x plus 3 not equal to 0. Again x square minus 1 can be written as x minus 1 into x plus 1 not equal to 0 or x plus 3 not equal to 0. Here x square minus 1 is in the form of a square minus b square. We know a square minus b square equal to a minus b into a plus b. So x minus 1 into x plus 1 not equal to 0, x plus 3 not equal to 0. Again we can write x minus 1 not equal to 0 comma x plus 1 not equal to 0, x plus 3 not equal to 0. Here x minus 1 into x plus 1 not equal to 0 means both must be not equal to 0. X minus 1 not equal to 0, comma x plus 1 not equal to 0 and x plus 3 is also not equal to 0. If we take minus 1 to this side, x not equal to 1 comma, here by taking plus 1 to this side, x not equal to minus 1 comma. If we take 3 to this side, x not equal to minus 3. So in place of x, don't take plus 1 or minus 1 or minus 3. Except these three values, by taking any real number, the function 1 by x square minus 1 into x plus 3 is defined. Except 1, minus 1 and minus 3, you may take any real number in place of x. So, 1 by x square minus 1 into x plus 3 will be defined. So, you may take any real number other than minus 1 comma plus 1 comma minus 3. So, we can take domain of the given function is any real number other than these three numbers, any real number other than these three numbers. So, r minus of plus r minus 1 comma minus 3, by observing the options we can take option C. In option B we have r minus of plus r minus 1 comma 3. In option C we have r minus of plus r minus 1 comma minus 3. So, that is why minus C. Option C is the correct option. So, in place of x, if we take 1 square 1 minus 1 0, 0 into something 0, 1 by 0 is infinity, not defined. In place of x, if we take minus 1 whole square 1, 1 minus 1 is 0, again 0 into something 0, 1 by 0, that is also not defined. In place of x, if we take minus 3 plus 3 0, 0 into x square minus 1 is 0, 1 by 0, that is not defined. So, except these three numbers, you may take any real number. If you take x equal 0, 0 minus 1 into 0 plus 3, 1 by minus 3, that is defined. So, defined means you must get the known value by substituting the value in place of x. So, except these three values plus 1, minus 1 and minus 3, by substituting any value in place of x, you must get the known values. So, since we are not considering these values, we can say the domain of the given function is r minus of plus r minus 1 comma minus 3. We can say the domain of the given function as r minus of plus r minus 1 comma minus 3. So, that is option C. In option B we have 3 only. In option B we have 3 only. So, r minus of plus r minus 1 comma minus 3 is the domain of the given function. So, dear students, hope you understood the class today. Let us do some more mains model problems related to domains in next class. So, thank you for subscribing Webmaster. So, please inform to your friends also about Webmaster and ask them to subscribe. Thank you.